Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have x log x, right? So what we've been given is dy by dx, and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down our y using the integral symbol. That's my y. Now my y has two parts to it, right? I have an x and I have a log x dx. Or you can visualize it the other way. I have a log x and I have a x dx, right? Now, can I solve this by the method of substitution? The answer is no. I don't think so because I am not in a position to connect x with log x dx or log x with x dx, right? Therefore, I don't think substitution is going to work out here. However, I do see that this particular function is of the format udv, right? So the point here is choosing the right u and the right v, right? I have two options. I have my u equals x or I have my u equals log x, right? Now, if I choose my u equals x, then my dv becomes equal to log x dx, right? Now, do I know the answer for v directly if I assume dv equals log x dx? The answer is no. Okay, so for a minute, let's park this substitution aside and let's come to the other substitution. Now I'm going to assume u equals log x and my dv equals x dx. So if my u equals log x and dv equals x dx, do I know the answer for v? The answer is yes, right? Therefore, let's go ahead and pick up the second substitution, what we just now discussed, and see if we can solve this problem, right? So here, my u equals log x, my dv equals x dx, right? Let's go to the next line and write down what is our du. My du is nothing but dx by x, right? Then my dv is x dx, and therefore my v equals x square by 2, right? I'm going to reserve the constant towards the end. So I have my u, I have my v, I have my du, I have my dv, right? So can I go ahead and apply integration by parts? The answer is yes. So what does our integration by parts say? I'm sorry, I should have written this earlier. My integration by parts tells me that if I have an integral of the form u dv, then the answer to that integral is uv minus integral of v du, right? And if you folks know why do we call this integration by parts, please do mention in the comments as to why we are calling this integration by parts. Some of the countries call this partial integration. Some of them call it integration by parts, right? I know that my LHS is nothing but the integral, so I write it as it is, which is integral of x log x dx. And then I have my uv. So what is my u? My u is log x, my v is x square by 2. Therefore, my uv is x square into log x by 2, right? That's my uv. Now I come to the next part, a minus of integral of v du, right? So what is my v? My v is x square by 2, right? So let's write down what is our v first before we jump to du. And then I have my du is dx by x, right? So I have my dx, I have my x, right? So I notice that I can cancel out the x in the denominator with the x square in the numerator. That's one simplification that I can do. And I can do one more level of simplification. And what's that? I can pull out the constant 1 by 2, right? So I'll be left with x square log x by 2 minus of 1 by 2 times integral of x dx, right? Now this is not very difficult from here on because I know the integral of x dx with whatever I've learned so far. So my answer to this problem is x square log x by 2 minus of, I have 1 by 2 already existing in the second part. My integral of x dx will become x square by 2. So I will have a 1 by 2 into 1 by 2, which becomes a 1 by 4. And I will have an x square in the numerator, which means my second part is nothing but an x square by 4, right? And not to forget my constant. So there we are. My final answer to this problem is x square log x by 2 minus x square by 4 plus c. So let me highlight my final answer in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.